Hi, welcome to the webinar session dedicated to the M1S COM, the newborn, uh, the newborn in our product portfolio, the newborn master unit in the Mosaic. Can you hear me well? I think yes. So today we are going to see what the M1S COM is able to do in order to understand the data exchange between PLC and other controllers in different field bus protocol. For example, we know from the previous webinar that the M1S COM is able to manage the communication with PLC that have Profinet protocol or Ethernet IP protocol or Modbus TCP or EtherCAT on board. So every protocol is built inside the M1S COM, the main unit. And let's start from the project from the previous webinar related to the MSD. So as you can see, we have the same project here. So we have the light curtain, the emergency stop, the RFID series, and the type 2 photocell. Plus today, we have also the real-time monitor of what is happening on the Mosaic M1S COM while we connect to the Mosaic, while we transfer, and while we have some diagnostic. Because the real added value for our M1S COM is to reduce the time for maintenance and for troubleshooting. And reducing the time means also reduce the cost. I can say it now that we are able to be very specific in the diagnostic. So when we exchange data to another level, to an higher level with the PLC, we can be very precise on what is the problem and where. So you don't have to spend more time to do the maintenance or the troubleshooting. First of all, let's have a look on what is possible to do with the M1S COM and all the data exchange. In the example today, we are going to use the Mosaic M1S COM in Ethernet IP. And as you can see from the real-time camera, this is the real-time camera, you can see my fingers. You will see that the module is connected only through the RJ45, and we are not using the USB Type-C. So we have on board, so this means that you don't need any extra module to transfer the data between Mosaic and PLC. We have all these feed bus already integrated. So Ethernet IP, Modbus TCP, Profinet, and EtherCAT. So again, we can also simulate, we will see the behavior of the system based on some diagnostic and based on the status of the inputs managed in this project and the output. So this is the simulation. Okay. What we have here is the total amount of allocated resource. So this means that we have, if you count here, we have 12 pins available for inputs. Of course, we can use 8 of them for example, the RFID, the light curtain, the emergency stop, and the type 2 photocell. But these 4 pins also are used mainly for feedback or reset purpose. So in this case, you can also change the behavior. So you can use those pins in order to manage other inputs. And we can say that in total on the M1S COM, we have 12 inputs. Then 4 of them are used also for feedback, control, or reset directly on the OSSD. 4 outputs plus 4 MI804 OSSD output, 4 status, and 4 MI804, plus all the field bus input and field bus probe. Now we will see what is possible to exchange with the M1S COM. Okay, we will see the mapping. This is the report. The report is the technical document that the machine builder must attach to the technical documentation of the machine. Inside this document, we have all the information. So the date here, the CRC code, the Mosaic configuration, the hardware configuration, cycle time, safety information, the amount of reserves, and the electrical diagram. As you can see here, every function block has its own description. So you can see RFID, light curtain, emergency stop, type 2 photocell, and the outputs. In this example related to the Ethernet IP communication, we are able to send 4 bytes as input in the module. So we can send 32 bits from the PLC to the main unit, to the Mosaic. And also in the report, we will see the IP addressing, the subnet mask, the default gateway, all the Ethernet information. As you can see, in this case, in Ethernet IP, we are able to give some information about the integration with some PLC. We have the integration files that you can find on our website. So ReeRSafety.com, under the download and software table, you will see the configuration file. For example, for the Ethernet IP, you can see the assembly instance is 96. So if you have to integrate with a generic device, use this assembly instance and put the size of 4 bytes. The same for the input. So the assembly instance is 64 in X, and you have to use a 33 byte as size. And what we are able to transfer. Okay, so the amount of information and what kind of information we are able to transfer from the Mosaic to the PLC. And this is the real added value to the Mosaic system. So on the first byte, we transfer the Mosaic status. The second byte is used for the next firmware revision. Then we have the input status of every device, every function block that we use on the M1S COM, every input function block on the MI804, plus all the expansions. As you can see in our real-time camera, we have only M1S COM plus MI804. If you use the 4 pins with special purpose as a reset input or any other inputs, you will see the status here. Then we have the feedback of what we are sending from the PLC to the Mosaic. So if we send some data to the Mosaic through the Ethernet IP field bus, we will use those bytes. But we expect to read the same information here. Then we have some field bus probe. The probe are used like breakpoints. So if I want to know, for example, if I pass through this logic here, I will use the probe and assign them. It doesn't make sense to use like this, because the status of this block is already transferred to the PLC. Of course, you can do it something like this. You can also do the copy and paste. You can do it, but it doesn't make sense because the status of every single block is already transferred, is already used in the field bus module. So let's go ahead. The OSSD status byte. And this is the status of every single OSSD function block that we use in our safety project. And these are what we call the cyclic data. So every every cycle of the PLC, we transfer this amount of data and that kind of data. But what if we have a diagnostic, for example? We have a miswiring or some signal is missing from what we're expecting from the safety project. Well, in order to understand what is happening, in order to reduce the time for the troubleshooting and the maintenance, you can use the explicit messaging. And in order to access to those data that are acyclic data, you have to use the service from the field bus. So is not something that we invented, okay? We use the service from the field bus in order to access to the diagnostic data. For the Ethernet IP protocol, we use the get attribute single service from Ethernet IP protocol. And what we are able to read, we are able to read the same data that we had before, plus the error data, the input diagnostic, the OSSD diagnostic, the CRC code. And if we use the RFID, and I suggest you to subscribe and to participate to the RFID webinar, you will see the information that we are able to exchange. So in order to access to those data that are very important, because look, the errors data is the fail-in LAD, and you can see that the fail-in LAD is the one that we have on the display of the Mosaic. The input diagnostic or the output diagnostic is related to the fail EXT, to the external failure. So we distinguish the failure, the internal failure, the errors from the diagnostic. Diagnostic is something that is related to the external wiring, something related to maybe the output test or some signal that is missing, or something is not congruent with the status that we expect to see from the safety project. So everything that is fail X is a diagnostic. Everything that is a fail in is an error. And why this is important? Because we also transfer the genetic information through the cyclic data. And I'll show you this. So we are able to collect a maximum of 16 diagnostic information for input and for the output. And we have the index and the code. Index is where, code is what. So if I have an issue, and in this case, you can see from the real-time camera that we have a external failure, and we have an OSSD that is blanking, is a continuous blanking. As a continuous blanking, we can say that we have a diagnostic on the OSSD. The software itself is able to automatically trigger this information, and the index is this code here. So index, where, and code, what. Later, we will see an example of how can we ask for this information. Then we have the CRC code, and this is also an important data because we can check the CRC code and, let me say, protect that someone put his hands on the software and change something, because we can continuously, we can ask every time to the module to give back the CRC code. So we are able to transfer the CRC code, the day, the month, the year, and the source. Because if you remember from the last webinar, from the first webinar about Mosaic, we have also the memory card, the MCM, that is able to provide the software, to download the software, you can use for a big backup, and you can also do the multiple download. So if you change something and then use the memory card, we can ask to the module, what is the CRC code inside your microcontroller and the source? So did we download from the memory card or from the software? And we have also this information. Then the Mosaic status, okay? Let me translate this into the LAD, into something that we are able to see immediately. As you can see, we have two green LED on top, that is on and run. Then we have two red LED, fail in and fail ext. Then we have the communication and the enable. Okay, let's focus on the first four LED. If we have online and run, we will see bit number 0 with true status. If we have the fail ext, the external failure, we will see the bit number 1 with a true data, with a true status. If we have the fail in, we will see bit number 2 as a true. And then, if we want to check the status of the function block related to RFID, and that's why in the previous webinar, I told you to use the description, because inside our report, we have also the mapping, and these make the software integration easier. So if I want to know the status of the complete series of the RFID, I just need to check the bit number 0. If I need to know the status of the light curtains, I will check the bit number 3. Emergency stop is bit 5 and type 2 photocell is bit number 7. So just by looking at the report, I will be able to read what is happening on the PLC. Same philosophy for the OSSD. So the output 1, 2, 3, and 4 is on from bit 0 to bit 3, and the diagnostic. So if we have a problem, let's imagine if we have a problem, okay, with some, I don't know, simultaneity or miswiring or output tests. I'm naming the most common issues with the wiring if we speak about inputs. If we have an error on the output test wiring, for example, on the emergency stop or a simultaneity error, the index will tell you where. The code will tell you what. So if we have a problem with the emergency stop, we will see index 3 and related code for the output test miswiring, for example, or short circuit to 24 volt. And the same for the output. If we have an issue like this case, and we will analyze this case, we will see this case right here. If we have an issue with the OSSD number 2, we will see index number 2. At the end, as you can see, you have to sign the document and you have to attach you, or who is responsible for the safety has to sign and attach to the technical documentation of the machine. So once we know all this information, we can close this, and I'll show you another feature that we have with the M1S COM. So during the Mosaic overview presentation, during the Mosaic overview webinar, we saw that with the M1S COM, we integrate also the scanning of the scan of the network. So let me delete this. I want to scan my network in order to find the M1S COM module. Okay. And as you can see, we have one M1S COM that is the one connected through the RJ45. I'm not using the USB, the Type-C USB. Sorry, the webcam is freeze. Okay, now is it working? I can also test the communication just to be sure that this is our M1S COM. Then click OK. We can go in connection always through the RJ45 and use the standard password that is SafePass because we want to download this information. Once we connected to the module, as you can see, the run LED turn it off, but the COM that stands for communication LED turn it on. We can also read the error history. We can also check the system configuration. We can also see the download history. And as you can see today, I downloaded twice this project. So all this information, we don't need the software, let me say, anymore. We don't need to see what is happening, to open the cabinet, to unwire everything. But what we have to do is just to communicate those data to the PLC. So by doing the right integration, we will be able to read those information on the PLC. So now we send the configuration. We have to save the project and send the configuration. Now it's not connected. I don't know why. Let me check again. Okay. Just download again. And we can also check this mark if we want this option, if we want to send the network parameter with the configuration. The network parameters are the same, so we don't need to send anything. So writing, saving the configuration, and verifying the configuration. We also upload the software here, so we can reset the entire configuration. And again, while we are connected through the RJ45, we can also do the real-time monitor. And first of all, if you or your customer needs to go in monitor and says, oh, every time I click the connection and I try to go in monitor, the machine stops because the safety system stops, is because you first connect here and then click on the monitor. A little suggestion, click directly on the graphical monitor. For the monitor, you don't need the level 2 password. You can use the level 1, and level 1 is empty because it's only for monitoring. Just click OK. And you can see status of the RFID, the logic, and the output. And as you can see, we have the OSSD number 2 that is blinking. We have the external failure, and the problem is the feedback unconnected in this case. So we have an issue with the feedback, and the diagnostic code is code 7. And what we expect to read from the PLC is index number 2, code 7. Another feature about the M1S COM, if I click on new project, project 2, for example, let's click OK, use the M1S COM. Then I can also go in connection, or if I already know the IP address, I can test, click OK, and says, oh, let me do it again without the page selection. Okay, for those of you that already know the Mosaic system but use the previous modules, this will be a great benefit of using the M1S COM. So connection. Okay, by using the M1S COM, if we read the project, so if we do the upload, let's click OK on the upload. Yes. This is what is happening. You will see the same description, same pages, same position, same comments, everything as we did before. In the past, the microcontroller move all the object and change the connection in order to be faster. In this case, we copy the same project into the EEPROM inside the module. So in this case, we don't need to reassign anything. And we can also go in monitor right here. You can see everything is in real time. Let me change a little bit the focus if I can here. Okay. So now let's see the what is possible to how we can read all this information. So for my examples, I use codices. Okay, so I made a project with the file from our website. Give me some seconds in order to open codices. I think you already know the software environment, you already know the system, but it's very easy to use and very easy to read all the data. And I show you how to read in the right way, okay, with the real example. This waiting time is for you because you can think about some questions maybe. And any questions, don't worry, we can answer at the end, or you can write to aftersales@reer.com.it, sorry. So let's go into this demo. Let's start the PLC. Open the project. I also made a small example of the diagnostic reading. So we will do it manually, but you can also trigger it automatically. Okay. So let me connect. Right here. Do the login. Okay. Okay, so the first byte is related to the Mosaic status. And Mosaic status has this meaning. Bit number 0 is Mosaic online, and we have the Mosaic online. Bit number 1 is diagnostic present, the external failure. And we have bit number 1. And this bit is related to the RFID. So if I open the door of the RFID, you will see the generic status that is 0. And you can see also on the LED. You can see it on the LED here. So if I close them, you can see LED turning on, turning off. The OSSD, all the other parameters are 0 because we have no output. But look at this. We are connected at the same time on the MSD and on the PLC. So the information, and we will go deep into this information on the next webinar. So I suggest you to participate and to see the next webinar in order to understand how to manage this data, how to exchange, how the RFID change the game by transferring this information on one single wire. So we can also share the information about the gate state and what I expect to see. We have the diagnostic present. So we need to know the diagnostic about input or output. In this case, our diagnostic is related to the output, okay? And how to read the diagnostic to the out for the output. As you can see, we have the class, the instance that is instance number 6, and the attribute is 5. So everything is set, but instance is number 6 here, and read it, okay? What we expect to see is index number 2, code number 7. And if I read here, index number 2, code number 7. I did it manually, but you can do it by using this bit right here, just to trigger the acyclic data. And every time we have the diagnostic, please give me the diagnostic about input and output. And you will see index code, index code, index code. And that's the only index. If I want to know the status of every RFID, or better, if I want to read the CRC code, so what is inside? We expect to see 46 4C in X format. So let me change this to hexadecimal. And we know the instance is 7. How we know it? From the report. So in the report, we have all the information. Please look, always look at the report. So the instance is 7. I expect to see the CSC, the CRC, and the date and the source. So if I ask it, look, 46 for C, and then day, month, year. If I change this to decimal, you can see it. 24, 5, it's 2024. But the example here is just to show you that we are able to collect all the information from the safety system and provide all the information to the PLC without doing any addressing. I don't need to assign anything. Everything is ready to be transferred to the PLC with only one code. Another example, okay? We will do the same example. We will see it also during the next the next webinar. I want to read this status, okay? We know that we opened door number 2. So the RFID chain is 8. So I go on my system here. I use 8. And it's 5. If I change it in binary, then you can see it. If I close the door again, you will see these data is true. So we properly transfer the information on the cyclic data for the safety information in Ethernet IP or any other field bus to the PLC. We have the status here. And if I read again the status, you will see the data, the right data here. So again, the real added value of Mosaic in general is to collect all the safety device to manage all the safety function of a machinery. You can expand, it's modular, you can add expansion based on the requirements. And with the M1S COM, you can also transfer the data to a PLC without using any extra expansions. Plus, you can also do the Ethernet connection, because if you see the real-time webcam, I'm not using the USB. I'm using the RJ45. And think about the potential of this solution in terms of reducing time for the maintenance, in terms of data exchange, and reducing costs for the troubleshooting. So we are at the end of this webinar. If you have some questions, this is the time, or you can also ask to our after sales department by writing at aftersales@reer.it. So please, this is your time dedicated to the questions. Okay, one question. If I have more than one M1S COM in the network, can I select the connection for download and upload? What you can do is to do the device scanning, and by knowing the MAC address, then you can choose where to download and where to upload. You cannot do it by clicking on the download, because in order to download or upload, you must be connected. Sorry, the webcam today is very. Let me check. Sorry for the webcam. Take this time for the questions, please. Okay, I'm here. The RFID function are only available with the ReeR RFID sensor. Okay, if you speak about the RFID function in general, no. You can use the RFID block, for example, this block right here, with any RFID. But the feature about the line is only provided by our RFID. And if you compare this also on the market, you will not find the same behavior. So this is what we add to the market with our RFID sensor. So it's not available, the serial line, the serial communication for other RFID. You can use the block like this, and you can use it with any RFID on the market. If you need this feature here, this is compatible only with our RFID, because it's not based on the fact that we made it and stop. It's based on the type of information that the RFID is able to send. If you have an RFID that is able to send the serial message of the series on a controller with the same time, with the same structure that we will see on the RFID webinar, dedicated webinar, then you can connect it. But this is very unique for our RFID. If not, if you don't use the RFID line, you can use as a generic RFID block and you can connect whatever you want. Okay. Other question, if I use the MBEM COM module on an M1S, do I have the same ability to upload the program change? No. The possibility to do the upload and the download through the RJ45 is available only with the M1S COM. How to block the upload from the M1S COM? By changing the password. Because we have a standard password that is also provided on the manual. If you want to stop, if you want to block anyone from uploading the software, you have two possibilities. Sorry, you can change the password, or you can apply a password to this project. If I save this project, okay, like this, and then I choose Mosaic protected file, okay, I can insert a password. Now it's 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. It can be numbers or charts. Sorry. I do it again. Save as. Mosaic protected file. Save. And then type the password. For example, like this. Then click OK. If I close the software and reopen again, the MSD software, give me a few seconds. Okay, if I try to open again the protected file, but I don't know this password, I will not see anything. I will not upload. I will not download anything. So we have, as we said during the MSD webinar, we have to distinguish access to the file and access to the upload function. Okay, if I want to block the opening of the file, I need to use that password. If we want to prevent the upload, just change the level 2 password and your customer will never upload the software unless you provide the password. Okay, any other question? Something that maybe is not clear, or if you want to go deeper into some matters. Can you send the PLC example? Yes, of course. Please write to the after sales at reer.it, for the request, we will send you this ReeR demo example. Is it okay for you to receive it in codices, or maybe you prefer something for Profinet or for Ethercat or for Modbus? Please let me know. Using the M1S COM connected with a Profinet PLC could be the same that use a ProfiSafe PLC? No, because Profinet is Profinet. ProfiSafe is a profile integrated into the Profinet protocol. So the way that is used into the ProfiSafe data exchange is different. But we are demanding the safety, the manage of the safety function to a safety controller. So we don't need ProfiSafe because we don't need now to exchange data. Of course, what we are planning to do is to working on something that is able to communicate as a Profinet device with a ProfiSafe device with higher level. But in this case, we cannot say it's the same. We collect all the safety function into the module and send the monitoring data to a Profinet PLC, that is different from a ProfiSafe PLC. Okay. Wait 1 or 2 more minutes. If you have some questions, I'm here. Okay, so can the M1S COM exchange safety data over Ethernet with another M1S COM? No, it's monitoring available only. The Ethernet connection is only available for monitoring function. Okay, guys. Any other questions? I want to remind you to write to aftersales.reer@reer.it, and we will be glad to support you also for the integration. I want to thank you for your attention and to remind you to subscribe to the RSafe webinar, where we will see the protocol, we will see what we have as a product portfolio, the possibility, some industry, some applications, and some real-time hands-on on the RFID. So thank you for everything and see you next webinar.